Okay, welcome back. In previous video, we talked about linear transformations, and I gave you a very simple definition of linear transformation, that if you have a transformation or function of this kind that generates an output, and if the same input can be mapped to output through a matrix multiplication, then we call that the function or the transformation f is linear. So in the last video, I gave some examples in which the output was a single real number and the input was sometimes a single real number, sometimes multiple variables. In this video, I'm going to talk about specifically about this scaling. So let's see how the scaling is defined. So the input is x, y, that's the input, x and y, and the output is actually a vector of two numbers, or you can call the two components. The output has two components, like the input has two components, the output has two components, which is the one component is sx into x, that's one component. The other component is sy into y, where this sx is a parameter of scaling, sy is parameter of scaling, can be considered constants because the input variables are x and y. Whatever written here is the variable, rest of the things are constant. Now we can represent these two variables as a vector, which means this. We can rewrite the same thing in vector form in this. That is just list of variables written this way. And that way the output is also a vector, which is sx, x, and sy, y. And you can now see this mapping from input to output can be achieved through this relationship, where the output, which is sxx, this is actually x bar, and this output is basically y bar, which is the output. So x bar is equal to this matrix times the input, and y bar, which is another component of the output, is again a matrix times the input. So because the mapping from input to output is achievable by a matrix multiplication, and the matrix does not contain any variable x or y inside, so this transformation is linear. So scaling is a linear transform, and it's a handy way of implementing scaling through matrix multiplication or any linear transformation. It is handy or easy to implement that through matrix multiplication. In the next video, I will show you how the matrix multiplication can transform a point to another point in Python. So hope to see you in the next video.